In this project, we've trained physically simulated humanoids to play a simplified version of 2v2 football, in North America also known as soccer. To achieve that, we use a combination of imitation learning, reinforcement learning, and population-based training. Before training, the physically simulated humanoids make random movements and do not produce competent behavior. After training a population of agents for 3 days wall clock time, or the equivalent of 5 years of simulated matches, the agents have learned the basics of gameplay, running towards the ball and scoring. After more training, the gameplay is increasingly coordinated and features longer horizon behaviors that reflect anticipation of the consequences of actions. Our virtual football environment consists of humanoid bodies simulated in the MuJoCo physics engine. The gameplay emerges as the agents that control the bodies learn to stand, locomote, and dynamically move to interact with the ball and the other players. Gameplay consists of 45-second bouts of play from random initial configurations. When a team scores a goal, each agent on that team receives a reward. Then the player positions are reset and the game continues. Note that our environment implements simplified football rules. There are invisible pitch boundaries that keep the ball in the field. Also, play is not interrupted by penalties or set pieces. Training of the agents is divided into 3 major phases: low-level motor skills, mid-level single-player drills, and high-level goal-oriented team coordination. The low-level motor skills are achieved by imitation of motion capture. Mid-level skills are acquired through reinforcement learning on drills and consolidated into priors for future use. Finally, team coordination is learned through reinforcement learning in the context of 2v2 games between teams drawn from a population of agents. The agent architecture across stages involves first training a low-level motor skill controller from the motion capture data. The learned controller is then transferred into the drill training and held fixed while training the drill-specific expert. The resulting experts are distilled into priors, which are used together with the low-level controller to train a population of agents in the actual football bouts. Consistent with the line of prior work discussed in the paper, agents acquire low-level skills by mimicking movements from motion capture data, in this case of people playing football. We then train experts on each of a set of drill tasks. These experts reuse the low-level skills from the motion capture, but must learn to utilize the skills suitably to achieve reward in each of the 4 drill tasks: following a moving target, dribbling a ball to follow a target, kicking a ball to a target, and shooting to score a goal. After training the agents on 2v2 games, we perform an extensive set of analyses to gain insight into agent learning, behavior, and representations. One analysis, shown here, visualizes which players control different areas of the pitch. We encourage you to read the paper for full details. The remainder of the video consists of highlights of behavior of trained agents in the context of 2v2 matches. Thanks for watching.